This is the plane view. So current here will be into the plane throughout the conductor. B bar is like this, and this is the track. This is a track. Okay, now what is the, now how the BIL force should act? B bar current, so the BIL force will act in this direction. Straight away you write it, there's a BIL force. Weight mg. What are other forces? Normal contact. It should act at these things. I'm just showing plane diagram. It is. What direction? Friction. The friction should act for pure rolling. So I don't know this equation. So as it is pure rolling, acceleration A, this alpha. So BIL minus F equal to MA. Then F into R is equal to, this is a cylinder, M R square by 2 alpha. Then A equal to R alpha along x-axis at the lowest point. Solving this, we'll get expression for acceleration and the friction. Friction you should not write mu mg. It's a rolling friction. Application of BIL force. Now, what is the power generated by BIL force? If I ask you, I think first we should get expression for the acceleration. So this will be solving this. F equal to MA by 2 will get it. Substitute here. BIL minus MA by 2 equal to MA. So what is the acceleration equal to? 2 BIL by 3M. The resultant friction I'm showing. Friction acted at both the places. The resultant friction is what we are showing. So this is the acceleration. Then what is the velocity of this at any time? V equal to 80. So 2 BIL by 3M into T. So what is the power generated by this? F into V. So 2 BI so it will generate power. It will generate power. So it is having ability what? It is having ability to do work. Let me store it. So any power related questions also will be asked for you. You have to be very careful. Anything related to power also can be asked. So 2 is there, no? Here. There's what? Power generated by ampere force. So just to make you think that it is just like any other contact force, what you studied in mechanics. Is it a dissipative force? Ampere force is a dissipative force. No, ampere force is a conservative force. It's not a dissipative force. Very important. They'll just may argue some set of in matchings. No, ampere force, Lorentz force. What do you mean by Lorentz force? Lorentz force is what? F equal to QVB. Ampere force is what? F equal to BIL. They don't give equations, just say Lorentz force, ampere force, all that one. Conservative, dissipative force, or just external force. Even the Lorentz force also conservative, but work done by it is 0. Because from where F equal to BIL has come, from F equal to QVB only. So Lorentz force is also conservative, ampere force also a conservative. They may just ask you to categorize the nature of forces. So what all you studied forces, no, you must know their basic nature. From where this power for this ampere force will come? The field. For the field, from where will come? External agent. Because somebody should generate this field, no? Somebody should generate that field. Some current carrying structure. and to make a current I in a structure, the cell should do work. So try to interlink the energy. A cell does work because of current I flows. If that current I flows in some current in a structure, some conducting sheet or something, then uniform magnetic field is produced. And so here what happens, that field what happens now does work on this cylindrical rod. So what is the energy transfer takes place in the cell? Chemical energy to electrical energy. Then the circuit converts electrical energy. So through that electrical energy, what happens when a current flows through a wire or through a rod here, they'll be converted into magnetic. Like when a current flows through some structure, then it will produce a magnetic field. This magnetic field is now doing work on it. This current